In this video, I'm going to talk about metals and nonmetals, and specifically about the properties of those metals and the uses of those metals and nonmetals. Before I start, I'm going to talk about which of these elements, this is the periodic table, which of these elements you can find in its non-reacted state. So, which elements are often non-reactive, which means they don't combine with any other element. They are usually found by themselves. So, for example, if you look at gold, which is here, gold that's an image of a gold mine. Gold is often found just by itself, so as Au, as opposed to reacting with any of the gases. You don't usually find AuO, which would be gold and oxygen combined. That's unlikely. Gold is often by itself because it's non-reactive, right? So if it's non-reactive, that means it doesn't react with anything else. It just stays by itself. As does, for example, neon. So neon, this here is neon gas, and that's the halogen. Sorry, not a halogen, but a noble gas. And noble gases don't tend to react with anything else. So they are non-reactive as well. They're just by themselves. Whereas one really good example of something that's quite reactive would be salt. So right here we've got our salt, and what salt actually is, or table salt at least, is NaCl. So Na stands for sodium, so that's this part of the periodic table, and Cl is chlorine, and that's on the other side right here. So both of these are very reactive, so you don't tend to find them just by themselves. They always tend to bind with something or form some kind of bond. In this case, sodium forms a bond with chlorine to form sodium chloride. So realize that some elements are more likely to be found by themselves because they're non-reactive, such as noble gases and some metals, whereas other elements, especially your nonmetals, your halogens, and your group 1 metals, they tend to be actually found with something, combined with something, because they're quite reactive. When it comes to this periodic table, what I also want you to know is that on the left-hand side, so all of these in red here are metals. So the vast majority of elements on the periodic table are metals. All of these are metals. The ones in blue are nonmetals. So you can see on your right-hand side, most of them are nonmetals. And then there's also hydrogen, which is on the left-hand side. All of these are your nonmetals. Now I didn't put anything on the group 8, which is these. These are also often classified as nonmetals or just as noble gases. So group 8 is special. They're often just called noble gases as opposed to nonmetals, but both names could apply. Right, so group 8 is noble gases, then comes your nonmetals. On your left-hand side is your metals, and in the middle, all of these yellow ones, they're either called metalloids, these ones, or semimetals. They basically have properties between your metals and your nonmetals. They're called semimetals or metalloids. And that would be boron, silicon, and so on and so on. There's only 6 of them. And last thing I want to quickly go over before I move on to the next slide would be to look at which of these are at room temperature, so at 25 degrees Celsius, which of these are found in what type of states. Remember, the states are solid, liquid, and gas. And at 25 degrees Celsius, so at room temperature, most are solid. So the ones I'm not going to actually highlight are basically solid. These here, so nitrogen, oxygen, fluorine, all of your noble gases, that's why they call it gas. Chlorine, these are gaseous, and hydrogen. These are gaseous at room temperature. Now there's 2 which are liquid at room temperature, and those are bromine and mercury, which is right here. These 2 are liquid, and the rest are solid, right? So we've got basically your gases on the left-hand side. You have your 2 liquids, bromine and mercury. One of them is metal, the other one is non-metal, and the rest of them are all solid at room temperature. I'm going to talk about some properties of metals and nonmetals, and these properties are general that all metals and nonmetals have in common. And we'll start with things like luster, hardness, ductility and malleability. All these are physical properties, so we'll only compare the physical properties of metals and nonmetals, and then we'll talk about how we can actually use them, those properties. So for example, of metals, each of these here is a metal: brass, aluminium, cast iron, copper. These are all metals, but they all have certain things in common. And this is one example of a non-metal, but all non-metals have things in common as well. Alright, so we've got luster. Luster is basically how shiny something is. So metals are, for example, very shiny, so that is obvious. Whereas if you look at this is non-metal. It might look pretty shiny here, but often if you see them in person, they look very dull, so they are not shiny. So metals are shiny, they have a very lustrous appearance, whereas non-metals are dull. Now when it comes to hardness, so hardness means how strong they are or how hard they are. Metals, we say they're strong or hard, whereas non-metals are brittle. It doesn't mean that they're soft, but what that means is if we were to actually try to break it, it'd be hard to break a metal, and if we break it, it would be a clean break. But if it's a non-metal, that means as soon as we put some pressure on, it will actually break apart in a non-uniform way, so it's brittle. That's what that means. Now we'll talk about ductility and malleability. Ductility is how easy we can make something into a wire, and malleability is how easy we can make something into sheets. Now, metals are very ductile. We know that because copper wires, different types of wires, we can make metals into wires. That's generally one property they have. So metals tend to be quite ductile. And they're also quite malleable, which means we can make them into sheets, right? So, for example, any of these metals, I mean, iron is one good example, or even copper or steel, we tend to find them in sheets. And that's because they are very malleable. Now, with nonmetals, it's opposite. So nonmetals are hard to make into wire, so non-ductile. The reason being is, again, they're brittle. So if we try to make them into wire, they would just break. And also non-malleable, which means we can't make them into sheets. Same reason, if we try to make them into sheets, they would break because they're very brittle. Now we'll talk about electrical and thermal conductivity. Electrical conductivity just means how easy is it for it to conduct electricity, right? So wires conduct electricity. So obviously this would suggest that metals are pretty conductive. And thermal conductivity means how easy do they conduct heat, thermal temperature, how easy do they conduct heat. Metals conduct electricity quite well. Again, we use copper wires because copper will conduct electricity quite well. And they will also conduct temperature or heat quite well. So we would say they conduct heat quite well. And we use pans that are made of metal for that reason, because all that heat from the flame actually gets into the pan, and we can use that to heat whatever is in the pan. Now, whereas non-metals do not conduct temperature well, and they do not conduct heat well, electricity well, so they're insulators as well. So basically, again, the opposite of your metals. They don't conduct electricity well, and they don't conduct heat well. When it comes to melting and boiling point, so that refers to at what point does it melt, at what point does it boil. Now, metals have high melting points and boiling points, and we know that because we would have to use a lot of temperature to make a steel structure, a steel bar melt, right? So we're talking about 700, 800, 900 degrees Celsius, very high temperatures. Whereas when it comes to nonmetals, so for example, gas, so oxygen gas, that oxygen is already has already gotten to its boiling point before it's even room temperature. So they tend to be quite low. Some of them are a bit higher, but they all tend to be relatively low compared to your metals. So metals have high melting and boiling points, which means we have to put a lot of temperature into it to make it melt and then make it go into gas. Whereas nonmetals have a much lower melting point and boiling point. And some of those gases, some of those nonmetals, oxygen gas or nitrogen gas, they're already gas at room temperature, which metals definitely aren't. And density just means how closely packed are they, like how much for 1 square centimeter or cubic centimeter, how much is in there, like how many atoms. And metals tend to be very dense, whereas nonmetals tend to have low density. Right, so those are some of the properties you should know. So you should be able to compare metals and nonmetals and some of those physical properties. Now, how can we use those physical properties to make use of them? And again, the pan would be one good example. So if we have a pan, what's going to happen is the actual part that is in contact with the flame, so the flame would be underneath here, the flame would be in contact with metal, and that metal would actually basically transfer all of that heat to the pan, and that will cause an increase in the temperature of the pan, and thereby an increase in the temperature of the food that we have in the pan, right? Because metals are good conductors of heat. That's why we use metals for that purpose. Good conductors of heat. Now, what you tend to find on pans, hopefully you tend to find rubber. So you tend to have your rubber where you actually touch the pan. That's because rubber is non-metal, and we said that rubber and non-metals in general are poor conductors of heat. So they are poor conductors of heat, which in this case is good, because that means that heat that is in the pan is not going to be transferred to the grip, and when you actually hold on to it, you're not going to be getting yourself burnt, right? So we want to make sure we've got a good conductor of heat on the actual pan surface, because that will heat the actual food. But the grip itself, we want to have that be an insulator, so we take non-metal, because that will be a poor conductor of heat, which means we don't burn ourselves. Another example would be your wire. So we tend to have the wire itself be copper is quite commonly used. Now, copper is a metal, and copper, we said all metals are good conductors of electricity. So that's good, because we can make sure that electricity actually goes from where it's produced to where it's needed for these wires. Now, what you tend to find around the actual wires is you tend to find rubber again, right? So that's meant to be rubber, and the rubber was an example of a non-metal. And the reason why we use rubber here is because they are poor conductors of electricity. And in this case, again, we want to have poor conductors, because if they're good conductors, that means if you touch a wire, you get electrical shocks. So we want to have a combination of a metal inside, because they will conduct electricity quite well, and rubber around it, because they'll be poor conductors, which means we're insulated from the actual electricity when we touch it. So we've used both metals and non-metals to achieve that purpose. So that's what you should need to know. You should need to know all of those physical properties of metals and non-metals, and how we can use them, or why we use them, in different everyday situations to produce a good quality product.